couple more seconds and then we will kick off. But thanks everybody for joining so far to our webinar. I'm Carolina. I will be one of your hosts today, and we will talk about some of the cutting edge climate tech in our portfolio right now that is really serving some of the big trends that we're seeing in our portfolio. Okay, I think we have a bit of a more stable number, so I will start with an introduction to what we will be up to today with the webinar. To start, just some housekeeping rules. So in terms of expectations, what we will and will not discuss today in the webinar, we will be focusing on some specific company and technology examples from within our portfolio, and we will not be going into details of the investment products that we offer at Carbon Equity. If you're interested in that, please go on our website. We have the information there, and you can book a call with our team if you want to learn more. In terms of introductions, please feel free to write your name and role in the chat if you want to introduce yourself to the rest of the participants, and then we can all know who's in the audience. If you have any questions throughout the webinar, you will see a button in the bottom of your Zoom screen with the name Q&A. Please put all questions in the Q&A box, and we will be monitoring it throughout the webinar. And at the end, we will make sure to leave some time for questions. In terms of the agenda, I will give a brief introduction to what we do here at Carbon Equity for those of you who are less familiar with us, and then we will dive into the content. We have chosen today to focus on two trends that we really noticed over the last year within our portfolio, and deep dive into kind of one solution area within each trend and give some examples of companies. So today specifically, we will be talking about low carbon baseload power within the energy sector and critical mineral extraction and recycling within the industry sector. About who you are hearing from today, I'm Carolina. I'm an investment manager with Carbon Equity. We also have my colleague Eva on the line, who is an associate here with us. We both sit on the investment and impact teams of Carbon Equity. What that means is we're in charge of selecting the investments we make through our fund-of-fund strategy, both fund investments and direct investments into startups. And we're also keeping track of what's happening in the portfolio in terms of performance, but in terms of also different trends we see. And that's really what we're here to talk about today. A brief introduction to Carbon Equity. So in a nutshell, what we do, we are a climate fund investment platform. So on the one hand, we aggregate a lot of individual investors, and on the other hand, we pool that capital and we invest it in a fund of fund strategy, which means we select a number of venture capital, private equity, and infrastructure fund managers that in turn will invest in portfolio companies. That means that if you invest in a Carbon Equity product, you get indirect access to about 150 or 200 leading climate tech companies instead of picking and choosing them yourself. That's our model. And we've been doing this for about 4 years now. So in that time period, we've raised about 300 million euros in assets under management. We have over 1,300, I should say, investors investing through our platform. And with the capital that we have raised, we have invested in 25 underlying venture capital or private equity funds that have in turn funded over 200 climate tech companies. Today, we have picked about 8 or so of those companies to talk to you about in more detail. And just some context on kind of why we do what we do at Carbon Equity. To solve the climate challenge, we kind of already know what the pathway to get to net zero is. So the solutions that we need to decarbonize are there. They're maybe in a lab, though that's a small portion of it. They're mostly actually already developing pilot plans, gearing up for mass commercialization, or already in global deployment. So what we saw at Carbon Equity is that the solutions we need to solve the climate challenge are already there. They just need a lot of capital to continue to iterate, deploy their solutions. So that's really the role that we see at Carbon Equity for venture capital, private equity, and infrastructure funding to play a role in helping financing the energy transition and in turn also make pretty good financial return with it. And a bit of context on what climate tech is, or climate tech within the private markets, what that covers. You probably saw in these slides that some of the examples here of solutions are quite broad. So on the one hand, you have sustainable aviation fuel and green cement, and on the other hand, you have technologies you're probably very familiar with, like heat pumps, electric vehicles, or plant-based dairy products. So really, climate tech is more of an umbrella concept for a range of sectors. I'll just walk you through what climate tech covers so that we all are kind of in the same page around that. For starters, of course, the energy sector. So we need to generate energy in a renewable way, which is also, by the way, one of the cheapest forms to generate energy today, particularly solar. And we need to find ways to store that energy as well. So that's really energy generation and storage. That's what the energy sector is about. Mobility, there we're talking about the way we transport goods and people around the world. So aviation, shipping, trucking, passenger vehicles, for example. The industrial sector is the second largest in terms of greenhouse gas emissions per year. There, it's really about how we make all of the materials that will go into our buildings, for example. So steel, cement, those are some of the heaviest generating in terms of emissions. Then the building sector itself. So when you're operating and using a building, you are also generating emissions, mostly through heating and cooling. So heating a building with kind of gas boilers or cooling it with air conditioning. And last but not least, the food and ag sector, which actually is the third largest in terms of GHG emissions. There's also a range of solutions, from the alternative foods to alternative fertilizers, stopping food waste, etc. And lastly, kind of the last pillar here is the carbon management sector, which is the kind of pillar that we need to build up from scratch. So that's carbon removal or carbon and capture and storage technologies. This gives you an overview of the universe of climate tech that we are then going to start kind of diving deeper and picking certain sectors to focus on. In terms of trends in our portfolio, when we started thinking about what technology should we highlight in this webinar, we said, okay, let's see what the most active sectors were in the past year. So we actually looked into our portfolio, all the new investments that were made by our funds, which were 75 investments. Where did they sit in terms of this sector breakdown that I just explained? And it was kind of quite clear that energy and industry were by far the sectors with the most deal activity. It makes sense because they're also the sectors with the largest amount of GHG emissions. So there's a lot of opportunity to make things more efficient, cleaner, cheaper through technology. So that's exactly, of course, the two sectors that we've chosen for today to talk about. I will kick it off with the energy sector, and then my colleague Eva will go through the industrial solutions. So within energy, essentially the pie chart you're seeing on this slide is one level deeper. So if we then look at all the energy deals last year in our portfolio, how do those split by solution areas? What you can see here is that, again, there's two slices here that are quite large, and those are the slices related to energy generation. On the one hand, we have solar and wind that we all know as the most widely deployed renewable energy sources. In our portfolio, we not only have kind of the infrastructure around solar and wind, but mostly actually the enabling technologies around them. So how do you deploy solar on rooftops through a marketplace, for example, or how do you do predictive maintenance on a wind farm to better service those assets? Those are the kind of technologies that would be in that bucket. And then you have another bucket called low carbon baseload power that you can see here on the slide. What that means is the term baseload power refers to a stable energy source. So kind of a energy output from a power plant that you can expect to be the same and that doesn't kind of quickly change over time. Because as we know, solar and wind are very intermittent. So there can be days or weeks or seasons with more sun or more wind. But there's also some renewable energy sources that are much more stable, so that can give you a constant power output. And those can be very useful, of course, for example, industrial processes that need to run 24/7 and can't take the risk of intermittency. And that is the topic that we've chosen to focus on for today, low carbon baseload power. And I will first talk about why this sector has gained so much deal activity in the last year and why we expect it to continue to be very active this year. I will give you some context first on this slide. So if you look kind of historically over the last 2 decades, load growth, or essentially energy demand, has been relatively constant since the 2000s and 2010s. Why? Because we came up with a lot of efficiency solutions like LED lighting that allowed us to kind of keep growing our economies with a bit less dependency on increasing our energy demand. So for the last 2 decades, energy demand, so load growth, specifically in the US, is where this data is related to, has grown by on average about 0.6 or 0.7% per year, which is a bit of growth, but not substantially. And in the coming decades, the current expectations are that average annual increase in energy demand will be 3%, which might not sound much to you, but if you put it in context of that being 4x or 5x what we've had over the last 2 decades, is actually quite a bit of workload on utilities to figure out how to service all this increased energy demand. On this slide, the graph I have is the prediction of the Energy Regulatory Commission in the US, called the FERC, what they expected peak demand of energy, so the highest point of demand of energy in a year, to be in the year 2029. And these are predictions they made in 2022, 23, 24. And what you can see is they've kind of been wrong in their prediction every year. So every year they think that in 2029 we will need much more energy. And there are several reasons behind why energy demand is increasing, specifically electricity demand. So on the one hand, we are electrifying a lot of things, heat pumps to electrify your residential heating, electric vehicles to electrify passenger cars. And in the future, we also want to electrify, for example, industrial processes if we can, because then we can transition them from fossil fuels to renewable energy. So that's one source of electricity demand. The other kind of big source that you might guess of is data centers. So that's just been quite a big topic in the news in the last couple of years since the generative AI boom. So on this graph here, what you can see is the demand for IT power from non-AI data centers in the purple bar, and then the additional demand on top of that from AI data centers specifically. So you can see we're now in 2025. In 2028, so essentially more than half of the total IT power will come from AI. And as you know, maybe AI data centers are built by hyperscalers like Microsoft, Google, Amazon, Meta, and they really need energy ASAP to start building these data centers and service AI energy demand. What that also means is there is a bit of an opportunity here maybe for renewable energy companies that can offer that energy, because these hyperscalers have a relatively high willingness to pay for electricity right now because they kind of need it ASAP to build their data centers. So there's a few companies in our portfolio that are benefiting from the AI boom by being able to offer a stable energy source, so a baseload power energy source that is lower carbon. I will first dig into one type of baseload power, which is geothermal energy, and then nuclear energy. So starting with geothermal energy, these are two companies in our portfolio that are really developing advanced cutting-edge technology within each of these sectors. The first one is Fervo Energy, that you might have heard of already. So Fervo Energy is really the leading advanced geothermal company right now, I would say. They have been applying advanced techniques from the oil and gas industry into advanced geothermal. So for example, they are innovating with horizontal drilling. So usually geothermal energy, you are using thermal energy that is naturally appearing in the Earth's crust. So you're drilling wells to tap into that heat, that energy source. And traditionally, we've been using geothermal energy for centuries, predominantly though in geographies that have, for example, volcanic activity or hot springs, and where that heat source is a bit closer to the Earth's surface, like in Iceland. But companies like Fervo are trying to allow us to have geothermal energy in more places around the world through these advanced techniques. So one of the things that Fervo does is they can drill vertically, but then also horizontally once you reach sufficient depth. That means kind of by default, your surface area that is touching that heat is much larger, and therefore your potential electricity output from your power plant is much larger. The other thing they're innovating with is a technique kind of similar to fracking within the oil and gas industry. So you're creating fissures within the earth to try to tap into those heat sources in places where it might not be so close. Fervo has already built a small pilot plant with Google, actually, in Nevada in the US, where they're using a small geothermal plant to power one of Google's data centers. And at the moment, as we speak, they are building nothing less than the world's largest enhanced geothermal facility in Utah, a power plant that is called Cape Station, that will begin delivering electricity next year. And the power from that plant is already contracted to very large utility companies in the US. Maybe one last thing to mention to Fervo, and this is for the technology geeks in the audience, is that the US has kind of set out what their goals are in terms of what they want to achieve for advanced technology. And Fervo has already achieved the US government's goals for geothermal that they were trying to accomplish by 2035. So over 10 years earlier. That's kind of the level of technology we're talking about. So this is actually a company that sits in our Fund 3 that we're currently raising. So if you want to get exposure to these types of companies, do feel free to reach out and check out our website. The other company I will mention is a more earlier stage company called XGS Energy. XGS is trying to decouple geothermal energy from its dependence on, again, specific geology, but also water. So usually geothermal companies will have to put water down a pipe and through fissures to kind of grab that heat from the earth. And what XGS is doing is they built a very modular unit, which is one kind of iron casing, iron tube, to call it that way, that goes into the earth, and then the working fluid, which is usually water, is passed through that iron casing and recycled continuously in a zero waste closed loop system. And then because they have this metal casing, it's a thermally conductive material. So that means they can attract or grab more of that heat from the earth. So this is still a technology that is being developed, but it could be a more modular way to deploy geothermal and could allow us to put it in even more places. And then the other baseload power I wanted to talk about, so the other source of renewable energy that can also be quite stable is, as we know, nuclear energy. And here specifically, I'm talking about nuclear fission, right? So not nuclear fusion, that could still work out down the line, but these are kind of advancements on top of how we build nuclear fission power. Yeah, the first one here that I want to talk about is Radiant. Radiant is also a company that sits in our current Fund 3 of carbon equity. So Radiant is building a portable microreactor that can replace essentially like a diesel generator. So these are reactors that are relatively small. They can fit in a tractor trailer or a shipping container. They're like 1 megawatt units. And because they're relatively small, it takes less time and less capital to deploy them. And it's much easier to design, kind of iterate the design of these reactors. They particularly serve, for example, remote communities, remote kind of industrial facilities, also data centers, for example, could be military bases as well. So places where you usually would use off-site power in the form of a diesel generator, now you can put one of these reactors that needs to be refueled much less often than a diesel generator. So you can put the reactor there for 5 years and then refuel it, and it can last you for 20 years, actually. The founders of Radiant came from SpaceX, so they have this kind of way of working of taking off-the-shelf components and designing it in a novel way to create a very innovative product. Radiant is on track to demonstrate their full reactor next year, and they already have purchase orders for dozens of their microreactors. So we're very excited about them as well. The last company I will talk about is Blue Energy. Blue Energy is taking, again, this is really off-the-shelf reactors. So from a technology perspective, less kind of innovative perhaps than Radiant, but they're making a new way to build nuclear power plants. If you're familiar with nuclear at all, you know power plants are quite time consuming to build. It can take decades to really license and build and operate a nuclear power plant. So what Blue Energy is doing is they're manufacturing nuclear power plants within shipyards, and shipyards are places that have the workforce, the automated machinery to build these reactors. And actually, what you can see on this picture is that part of their innovation is that they submerge a nuclear reactor in a pool of water. Why do they do that? Because it gives just physical protection and kind of also cooling for the reactor, and it allows it to be built in a very kind of safe environment. And this way of working can reduce the construction time of a power plant from about 10 years to 2 years, and hopefully could make nuclear the cheapest baseload energy source, much cheaper than fossil fuels even. So yeah, 2 companies within this sector that we're very excited about. Happy to take any questions if there are any right now. Let me check. Not directly on the topic, so general questions we will take at the end of the webinar. Great, so I'll hand it over to Eva.
Great, thanks, Carol. This was a great start, I must say. So the second sector where we've seen a surge in 2024 was industry, and that's great because industry covers a quarter of our global emission problem. So big problem. And interestingly, within industry, we saw a lot of deal activity in textile recycling, but even more in the critical mineral space. And to us, this was actually not a big surprise. So to start with, what are critical minerals? I will briefly touch upon what these are. So these are raw materials that are essential for tech development, especially in industries like renewable energy technologies, batteries, semiconductors, but also defense technologies. So you can think about electric vehicles, solar panels, wind turbines, and electronics like your phone. And these materials are super difficult to substitute. So in many cases, there are not really alternatives for them. So we really, really need them. And examples of some critical minerals you might know are lithium. These are used in batteries, cobalt, also used in batteries, but also for aerospace and magnets. Nickel, more stainless steel, graphite, also batteries, and gallium, which is used, for example, in computer chips, and many more. So most critical minerals are mined, like lithium, that can be sourced in Australia, Chile, China, or cobalt, where the major suppliers are really coming from Congo, Russia, and also Australia. And as you might know, the mining sector faces major climate, social, but also environmental pressures. So why now? Why are these critical minerals a key investment theme at this point? So first of all, there's a rising demand from climate tech and AI, like you already mentioned, and this is happening globally. So these transitions are super mineral intensive. So like I said, the electrification, renewable energy, and grid expansion technologies require a lot of minerals. And then also AI and the semiconductor space that are growing rapidly and also require a lot of those rare metals. And then secondly, the supply chains of these technologies I just mentioned are heavily concentrated in China. And that you can also see on this graph. So what we can see here is that almost 90% of the global battery cell production is based in China. And then the lithium refining, the graphite production, the cathode production, the anode production, which are all crucial intermediate steps in this whole battery production chain, are also predominantly in China. And more countries are seeing this global reliance on China as a serious strategic risk. So therefore, we see a movement happening where governments and industries are seeking alternative supply chains for these critical minerals. For example, by investing in more domestic and more sustainable sources of critical minerals, or by really developing alternatives of the metals, or by focusing on recycling and circularity of the critical minerals that are already out there. So to give you an idea of cool climate technologies that are doing this already at this moment, I will also walk you through a couple of examples. So first, how can we extract minerals in different ways? So on the left side, you see Macrothea, and they developed a process to produce magnesium carbon-free without mining and domestically. It's thereby displaces magnesium that is also mined in China. I think 85% of all mining magnesium activities are based in China. And it also displaces local magnesium recycling, which has a bit of lower purity, which makes it harder to use it. So how does Microtia do this? They extract magnesium from seawater. So they buy waste brines. They allow the water to evaporate, and that leaves behind magnesium chloride salts. And then Microtia passes an small electrical current through the salts to separate the salts and are then which are then further processed into pure magnesium. I find this company super exciting. They recently signed a partnership with a big global car manufacturer, and they've received a 20 million grant from the US Department of Defense, as magnesium is also critical for defense technologies. And then on the right hand side, Lithius. They developed a method for extracting lithium, super important mineral for batteries, and they can do it worldwide. So today, moist lithium is either mined in hard rock, so it's quite hard and expensive to do that, or it's captured by evaporating briny water also on big salt flats. That's also super expensive, it takes a lot of time, and it's geographically limited. And that all while the EIA expects that lithium demand will be 42 times higher than it is today. So how do they do this? They use a lithium-rich brine, and that also passes over an electrified compound, and it works kind of like a sponge. So it absorbs the lithium, it ignores all the other materials, and then when the sponge is full, Lithius drains that briny water, turns it into a mix of more concentrated lithium water, and kind of opens up a fresh water tap, reverses the process, and then the lithium flows out of the sponge. So now you have very concentrated lithium water, and this entire process was really built to minimize water use. So you can inject the water back into the ground and reuse the lithium concentrated water. So this company is now scaling its system from like a small lab experience to a solid pilot plant, and it works already on 16 different types of brines that are coming from North America, South America, and even Europe. I will now focus a bit on different types of mineral, how we get these minerals, and that's more recovery and recycling. So two companies again. The first one is Citration. They recover minerals from mining waste, and it thereby solves an important problem because mining produces a lot of waste, and this waste is stored in so-called tailing ponds, and those hold the toxic chemicals and the byproducts of that mining activities. But increasing demand in critical materials results in even more waste, and this is so much waste that some mines have run out of room even for these ponds. So it's super costly as well to deal with this waste, and that's where Citration steps in. So they use equipment to treat the wastewater and harvest even more minerals in the process. Very low cost, very efficient, and they can do this with filters that are made out of silicon. And if you use silicon, that means that you can also use an electric current. And with an electric current, you can even extract more minerals like platinum, cobalt, and nickel as well. So as this company is growing, Citration plans to deploy its filtration system also with other partners, like big metal refiners or battery recyclers next to the current mining activities. And then finally, redwood materials. So where Citration, but also Macrothea and Lithius are quite an early stage company, redwood is already in its late growth phase. And they have already around 200 million revenues. It was founded by a co-founder of Tesla. And what they do is they recycle components from used batteries. And last year, I think they recycled 20 gigawatt hours of batteries already. So they do this by using quite an old school chemistry, which is super effective still. And their differentiating factor is that they bring the recycled materials directly back to the cell manufacturer. So it's kind of like a closed loop system. They recycle batteries on super big scale. And by doing this, they save a lot of energy, water, and emission. So this company is currently constructing the first commercial facility in the US. They also secured a 2 million loan from the government to really build up supply chain for EVs in the US and really facilitate that domestic production. And several names we all know they're working with are Panasonic, Amazon, Ford, Toyota. So doing well. So overall, super excited about those four companies to really further scale, as it's super obvious that we really need these technologies now more than ever, and not only to avoid emissions and avoid environmental harm due to mining activities, but also help to build these clean technologies we need. So I think these were all the companies. We'll now move to Q&A. Let's see what questions you have. Just feel free to put questions in the Q&A chat. I think first question on a geographical focus of the investments and if there is an investment bias, for example, focus on the impact in Europe. I think for carbon equity, like our overall portfolio, we aim to invest in both geographies almost equally, a bit more towards the US, I must say. And I think that the companies we discussed here are almost all US based, except for the one nuclear company. I think that's a Europe company. So no, we and can be that they're based there with their headquarters either in the US or in Europe, but many of these companies are really globally expanding now. So Redwood already is building a supply chain facility in Germany. Macrothea has contracts with potential magnesium off-takers in Europe. So yeah, you see these companies go quite broad. Any other questions that came in? Kara, if you any?
Yeah, I see one more here from Albert asking, obvious question in these turbulent times. Do you anticipate any headwinds for these companies with the new Trump policies? Actually, I was just thinking about this with the geographical question, but we've kind of chosen themes or sectors that are well within the Trump agenda. I think investors, especially investors in the US that are on the ground, are not dumb. So they have been iterating their investment strategy or refocusing to themes that they knew the administration would support. So actually, if you go now to the new Department of Energy Secretary in the US called Chris Wright, he has published his agenda for the new administration in terms of the energy policy. And it's really focused on energy abundance. So really what we talked about today, baseload power energy sources, going back to very stable energy sources, which includes fossil fuels, of course, but very much also nuclear, geothermal, and hydropower. So just last week, for example, Texas, the state of Texas announced their nuclear renaissance bill. So they're really going full support for new reactors within the nuclear sector. And the other topic that Ava talked about, critical minerals, is very important for geopolitical independence. So as you saw in that graph, 70 to 90% of supply chains for batteries and solar panels are in China. And Trump clearly wants to decouple from China. So there's going to be certain sectors within climate tech that I think will actually be accelerated by the Trump administration. And there's certainly going to be some sectors that will be de-accelerated. For example, technologies that are quite far away from price parity with fossil fuels today, like sustainable aviation fuels or green hydrogen. Those technologies probably will be better served by the European and Middle Eastern markets in the coming years than the US market. I hope that answered the question. We got another question now from Vilko asking, is there a minimum lifetime of the companies you invest in? In other words, new technologies, yes, but there must be a kind of critical mass capacity to make them survive the valley of death. Okay, so I think your question is about the maturity of the companies we invest in. In our fund of funds, our approach is really to offer very diversified exposure. Most of our portfolio will sit in kind of the Series A to D, which I would call the early growth or growth equity type investments. So these are companies that have usually a proven technology and needs to scale it up through a first planned commercial scale deployment kind of phase. So these will be usually revenue generating companies or close to revenue generation. Within our fund of funds, we will do very few select investments to funds that go even earlier at the seed stage, and a few commitments to funds that go later, like a buyout fund. Hope that answers that one. Then Ole asks, would like to know more about your ESG reporting. Do the funds you invest in do this, or are you in contact with individual startup companies yourself? Yeah, maybe Eve, do you want to talk about how we do our substantial kind of impact assessment and reporting to our investors?
Yeah, sure. So yeah, there are actually two types. There's ESG reporting, which is a lot about like the risks a company is exposed to in terms of environmental, governmental risks, social risks. But we also do like the impact reporting, and that's really so we don't or a part of our fund invest directly into companies, but we mainly invest into funds. So what we on one hand do is we assess how the fund manager reports on ESG risks and also on impact, so in terms of avoided emissions, for instance. And then on the other hand, we have our own reporting towards our own investors. And for that, we developed our own methodology to assess all the underlying companies in our portfolio. Based on whether we believe these are substantial building blocks for a zero emission economy. So yeah, we have a stepwise approach how we assess that, and the most important things are: do we think this technology tackles a big emission problem, and does it really contribute to solving this emission problem? And then we also look at the unit impact of a technology, meaning how big is the impact delta of that company versus the incumbent technologies we have today. And yeah, those two, we ask those questions for each company and make an assessment based on that. And yeah, that lands on whether a company is substantial contributing to net zero, and we report on that metric ourselves. I hope that answered the question.
We have actually two questions right now, both about heat pumps. So one asks, are there any new companies in the residential heat pump sector? And the other asks about startups that are in the low and high temperature heat pump sector. And we certainly have quite a lot of these in our portfolio. So maybe I'll start with the residential heat pump. We have companies that are manufacturing kind of highly efficient residential heat pumps. For example, Quilt in the United States, or IRA here in Europe, out of Sweden. We also have companies that are trying to not manufacturing themselves, but just installing the heat pumps and then connecting them together to the grid to use them as a source of distributed energy, kind of grid flexibility play. We have a company called Vamo in Germany that is doing that model. And then more on the higher temperature heat pumps, so the more industrial applications for heat pumps. We also have a couple companies in that space. One is called Atmos Zero, which is an American company, but actually also has an office in here in the Netherlands. And they're developing a heat pump that can be used for industrial applications. So to replace fossil fuel-based heat, for example, in like a pulp and paper facility or a chemical production facility, situations like that. And actually, maybe good to highlight, our first exit out of our portfolio was a company called Heaton, which I believe was a Norwegian company. They were bought by private equity out of our portfolio, and they are also developing an industrial heat pump. So a lot of activity in that sector for sure. Great. I think those were all of the questions. If we didn't answer your question fully, do feel free to reach out. We're happy to have a further conversation about it. But for now, we're 5 minutes early. We will stay. Oh, question just about if the presentation will be shared with the audience. I believe we will share a recording with the audience afterwards. So yes, you will get access to what we talked about today. Great. Yeah, if that's all the questions, I would like to thank you all for joining us today. We hope you learned something. And if you want to know more about carbon equity, just to highlight here, I mentioned some of the companies that we discussed today are part of our Climate Tech Portfolio Fund 3, which we are closing soon. So we've deployed quite a bit of this fund already, and the fundraising process will be open until the end of March. So if you want to gain exposure to cutting edge technology like the one we discussed today, do feel free to reach out. On our website, you can really browse through the entire fund and all the companies that are in there. So yeah, thanks everybody for joining. Pleasure to having you.
Thank you all.